Right, so the current population of a threatened animal species is 1.9 million, but it is declining with a half-life of 25 years. How many animals will be left in 35 years and then in 80 years? So looking at this problem, I see a couple of important things. One thing I see is that they gave me 1.9 million as my initial value, and they wrote it in words. I need to write that out as an actual numerical value. Because none of the formulas allow us to put the word million in there. So 1.9 million is 1,900,000. So that's important. That's our initial value. I also don't see any percentages here, but I do see a half-life of 25 years. So this tells me I'm going to be using the half-life formula. So my half-life is 25 years. Now, if you don't already have note cards and formula sheet for chapter 8 ready, you can always go to the SSU's website, go to chapters 8, 9, and 10, notes and examples, and you can look at our notes here as sort of a springboard. You can print these out, you can copy them down yourself. We're going to be using these for this video, and we're looking for half-life because it's declining and they specifically said half-life. So here we go, half-life. And this is the formula here, all in bold. The new value is equal to the initial value times 0.5 to this exponent here, little t divided by big T. That little t is the amount of time passed, and then the large T is the half-life. So in our case, we have all this information. We have the initial value, the 0.5 is always 0.5. We have the time passed, and we have the half-life. Let's plug it in. So the value after 35 years is going to be equal to the, original value times the half. Now, little t is time passed, and for us, the first time around, it's 35 years, and then the half-life is 25. So I'm going to plot this into Desmos. You can use any calculator as long as it's a scientific calculator, but I like Desmos. So let's see, 1,900,000 times 0.5 to the power of this fractional exponent of 35 over 25, and it looks like we have 719,965. So after 35 years, the population goes from over almost 2 million down to 700,000. That's kind of a bummer. It's probably not going to be much better if we plug in the value of 80 years. In fact, it's definitely not going to be better. But to do the 80 years, we're just going to do the exact same thing we did before. We're going to take our initial value, half to the power of this time 80 over 25. And I'm just going to go back in here and change out that 35 for an 80. And this time it looks like we're down to 206,756. If I round that to the nearest whole number. So 206,756. 206,756. And so this is how you can use the half-life formula given the half-life and the starting value and time passed.